Today's lesson is all about complex numbers. We have not went over complex numbers yet, so this is all new, but very, very familiar rules and procedures for complex numbers, and you're going to see why. So what should I know by the end of the day? The do now is going to be a little bit after this. So I can define the set of complex numbers. I can add and subtract complex numbers. I can multiply complex numbers. I can explain and show why it is mathematically incorrect to multiply square roots that have negative radicands. I can divide complex numbers, and I understand the similarities and differences between operations involving complex numbers and operations involving radicals. So, what is a complex number? So, the complex number are they are the set of numbers in the form of a plus bi, where a and b are real numbers, and I is the imaginary unit, which is radical -1, which we always write with I. So the real part of the complex number is a. So a is the real part. Let me separate that. So the real part is a. And the imaginary part is b. So we're going to look more into what qualifies as a complex number in A, B, and C. So let's take a look at A. It says, what can be said about a complex number where A is equal to 0? Take a second, take a couple minutes, pause the video, and think about that. Try and answer that question, and play it once you're done. So whenever it says, what can be said when A is equal to 0, let's just set A equal to 0. So if A is 0, that would be 0 plus bi, which 0 plus bi is just bi. And is 0 a real number? Yeah, it is. So that's fine. So what can you say about it if a is 0? Well, that's just an imaginary number. So when a is equal to 0, the simplified, or you can just say just the complex number, the complex number bi is what kind of number is it? An imaginary number. And is it still complex? Yeah, it's still a complex number because the real part just happens to be 0 in this case. And the imaginary part is bi. B, in this case, is a real number, so this is still a complex number. What can be said about a complex number where b is 0? Take a second, pause the video, and try and think about this one. Try and reason it out. Play it once you're done. So let's see what happens when b is 0. So we have a, which is a real number, plus 0 times I. 0 times I is just 0, so that would be a plus 0, which is just a. So when b is equal to 0, what can we say? The simplified complex number, the simplified complex number is what? Well, simplified complex number A is a real number. So complex numbers both have a real component and an imaginary component. Sometimes it's just all real. If the b happens to be 0, it cancels out the imaginary, and it's the real number a. But say a is 0, it cancels out the real part, and it's just the imaginary number, whatever bi is. So what conclusion can you draw about your responses using parts A and parts B, part A and part B, about complex numbers? Think about that for a couple minutes. Pause the video and play it once you're done thinking about it. So, complex numbers include plain old imaginary numbers and also real numbers. So complex numbers include both real and imaginary numbers. The set of complex numbers includes all real and imaginary numbers. So every single number that's real and every single number that's imaginary is a complex number. So a complex number is every single number you've worked with so far up until today. So that's just your first time hearing of the actual name complex numbers. So on the next page, I brought back the number web. The set of complex numbers is both real and imaginary numbers. So every single number, both real and imaginary, are complex numbers. So let's go to the next page. I want you guys to this is going to take a little bit. Take 5 to 10 minutes. Do 1 through 6. And then do number 7. We have done very similar things to 1 through 5. And then I think for 5, you can reason out. Look at 5 and then try 6. So make sure you do 5 before 6 for this do now. Don't skip around. Pause the video if you haven't already and didn't hear my rambling. And play it once you're done and we'll go over it. So I completed 1 and 2 before doing the rest. 1 and 2 radical expressions. We've already done this. So looking at 1, I distributed the negative inside of the second parentheses and then just combine like terms. And number 2, this is important. What I do first, I simplified the radicals first. So radical 18 would be radical 9 radical 2, which is 3 radical 2. And I did the same thing with radical 72. That would be radical 36 radical 2, which is 6 radical 2. And just double distribute, multiply, and combine like terms. So for number 3, I wanted to show you guys it's very similar adding and multiplying imaginary numbers and complex numbers, to adding and multiplying radicals. And we're going to talk about why that's the case, number 7. So number 3, all I'm going to want to do here is just distribute that negative. So it'll be 3 plus 5i minus 7 plus 2i. Combine like terms, you get negative 4 plus 7i. Notice very similar to when we were adding radical expressions. And number 4, 1 minus I to the 17th times 3 plus I to the 19th. We're going to want to simplify the powers of I just like we simplified the radicals in number 2. So that would leave us with 1 minus, I'm going to do work off to the side, 17 divided by 4 will be 4.25. So that's a remainder of 1. So it would just be plain old I times 3 plus 19 minus 19 divided by 4 is 4.75. So we'd have a remainder there of 3. So that would be I to the third, which is negative I. I'm going to simplify that one more time. So 1 minus I times 3 minus I. And now I'm going to do what I would normally do. I'm going to double distribute. 1 times 3 is 3. 1 times negative I is negative I. Now negative I times 3 is negative 3i. And negative I times negative I would be plus I squared. Let's continue to simplify. So that would be 3. I'm going to add those i's together. Negative 1i minus 3i minus 4i. And then I squared is negative 1, so we minus 1. And combine the last two like terms. 3 minus 1 is 2, so it'll be 2 minus 4i. So very similar process so far. Let's look at number 5. Number 5, we are dividing a radical expression, and our denominator is irrational. We can never have an irrational denominator. We have to rationalize it. So what do we do to rationalize our denominator? Well, we have to multiply by the conjugate of the denominator in the numerator and the denominator. So that would be 2 plus radical 10 is getting multiplied in the numerator and denominator. So let's multiply the numerator first. 3 times 2 is 6. 3 times rad 10 is, 3 rad 10. Over, let's make sure we multiply everything in that denominator by everything in the conjugate. 2 plus 2 is 4. 2 plus rad 10 plus 2 rad 10. Negative rad 10 times 2 minus 2 rad 10. And negative rad 10 times positive rad 10 would be negative rad 100 or negative 10. Let's simplify it from here. The numerator doesn't have any like terms, can't do anything there. Denominator, it does have some like terms. The plus 2 rad 10 and minus 2 rad 10 cancel out. And we're left with 4 minus 10, which is negative 6. Let's take out, we have a common factor of 3 in every single term. So we can divide each term by 3, and we get negative 2 on the bottom, 2 and 1. So our simplified answer would be 2 plus 1 rad 10. I'm just going to write it as rad 10 over negative 2. And one more thing, we're still not done yet. We can't have a negative denominator, so let's just bring that negative to the top. So we're going to change the sign and everything in the numerator and put it over positive 2. Looking at number 6, we're going to want to do the same thing as we did in 5 in number 6. We can't have an I in the denominator. We can't have a imaginary part in the denominator. So what we're going to want to do is multiply the top and the bottom by the conjugate of 2 minus I. So that'll be 2 plus I and 2 plus I. I don't know if any of you guys thought of doing that, but so we multiply the numerator the same exact way. 3 times 2 is 6. 3 times I plus 3I over 2 times 2 is 4. 2 times I is 2I. Negative I times 2 minus 2I. And negative I times positive I is minus I squared. No like terms in the numerator, so we'll leave it as 6 plus 3I. Let's look at the denominator. We have the i's, 2I and negative 2I cancel, and we have 4 minus negative 1, because I squared is negative 1. Let's see, I'm going to keep change, distribute that negative, and we're left with 6 plus 3I in the numerator over 5. Now, this is key. I know I didn't say to do it in the do now, because this is, something newish that we're doing, but you always want to write this in A plus BI form. You always want to write it as in a complex number form. So what we're going to do is we're going to separate each part. So 6 over 5, separate the real part, plus 3I over 5. So it separates the real part A from the imaginary part B. And I'm just going to write this as 6 over 5 plus 3 over 5I. So we got that in the A plus B I form. Now, take a second. Why do you think that operations with radicals and operations with complex numbers follow very similar rules? Well, think about it. What is I? I is just radical negative 1. So I is a radical number. It's just the square root of negative 1. So it makes sense when we have a complex number, when we have i's, it's going to follow very similar rules to radical operations. let's go to the next page. You guys are going to see more of that. So for adding and subtracting complex numbers, make sure we write it in a plus bi form. I'm going to make sure we write it in a plus bi form because every question is going to say that you always want to write your answer as a simplified complex number. So when I look at number 1, we are subtracting complex numbers. So I'm going to distribute that negative on the inside and change all the signs of that second parenthesis. So that would be 11 minus 6i minus 7 minus 9i. And then we do what we have been doing. We combine the like terms, which in this case are the integers, the real numbers. And then we combine the imaginary numbers. So that would be 11 minus 7, which is 4, minus negative 6i minus 9i minus 15i. And that is an a plus bi. I know it's minus, but it's still fine. A plus bi form. Perfect. That's our answer. That's all you got to do. Number 2, very similar rules. Simplify what we can simplify. Well, we can simplify I to the 7th. That would be 7 divided by 4 is 1.75. So that would be I to the 3rd, which is negative I. So that'd be 11 minus 6 times negative I. And I to the 13th is just going to be 13 divided by 4 is 3.25, which is just I. So it'll be minus 7 plus 9i. I'm going to simplify it one more time. That'll be 11 plus 6i minus 7 plus 9i. And distribute that negative on the inside. So that'd be 11 plus 6i minus 7 minus 9i. And combine like terms from here. You should get 4 minus 3i. And that is an a plus bi form. So we're good. Number 3. So number 3, how's this one a little bit different? Well, we have square roots that we need to simplify here. So this would be 3 plus, take the I out, and we are left with radical 4, which is 2. So that'd be 2i plus 7 minus radical negative 25 would be an imaginary number I, and then radical 25 is 5, so minus 5i. That's all you gotta do. We simplified any terms. Now we just combine like terms, added like terms. So we add the real parts, that'll be 10. Imaginary parts, minus 3i. And the last one, number 4, then we're moving on to multiplying complex numbers. We first need to simplify any terms. So we have 19 minus 10. Take out the I, and we have radical 125, which is radical 25, radical 5, minus negative 6 plus 3. Take out the I, and we're left with radical 48. The highest perfect square that goes into 48 is 16. So we have radical 16 and radical 3. And if you guys are a little iffy on that radical simplification, make sure you go back to the previous lessons. Maybe look over some questions there. Do some of the classwork if you haven't already. So from here, let's continue to simplify. That will be 19 minus 10i times 5, radical 5, minus negative 6 plus 3i times 4, radical 3. Let's write those imaginary parts a little bit nicer. So that would be 19 minus 50i rad 5 minus negative 6 plus 12i rad 3. Distribute that negative in. So we're going to have 19 minus 50i rad 5. Nothing changes there. Then once you distribute the negative, you have plus 6 minus 12i radical 3. Combine like terms, that would be 25. Those are the only like terms. Look at our imaginary part. We have minus 50i radical 5, and then we have minus 12i radical 3. So they aren't like terms. We can't combine them. So it would just be minus 50i radical 5 minus 12i radical 3. I would allow that. That would be fine. Some teachers might not allow that, especially if it says a plus bi form. Technically, a plus bi form, what you would have to do is you're going to have to now factor out the i's, and it would be 25 minus, put the b part first, 50 radical 5 minus 12 radical 3. So you're factoring out the I. So that is real a plus bi form right there. Notice how I factored out the I. So our a part is the 25, and our b part is the 50 rad 5 minus 12 rad 3. You could see this in some questions. I would just write it like that, but that's it for adding and subtracting complex numbers. Let's go to multiplying. Multiplying complex numbers. Gotta change the color, that's important. So simplify each of the following expressions in a plus bi form. Gotta get in simplest a plus bi form. So, looking at number 1, all we need to do here is feel free if you guys want to give this a shot. Do 1 and 2 and then play the video once I'm done, once you're done, and see if you're correct. But I'll just go over 1 and 2. So number 1, just distribute that negative 5 inside. And you're left with negative 5 times 2 is negative 10i. And negative 5 times 8i would be negative 5 times 8 is negative 40. I times I is I squared. But make sure you simplify this all the way. So negative 10i stays put, but minus 40 times negative 1. And negative 40 times negative 1 would be plus 40, but you need to put this in a plus bi form, so the imaginary part and the real part gotta flip. So it'll be 40 minus 10i, so we put it in a plus bi form. Number 2, we double distribute. Make sure you multiply 10 by everything on the right and negative I also by everything on the right. So it'll be 10 times 3, which would be 30. 10 times negative 4i minus 40i, and then negative I times 3 minus 3i, and then negative I times negative 4i plus 4i squared. Simplify what you can. 30 minus 43i, when you combine the i's, plus 4i squared is negative 1, which then makes 30 minus 43i minus 4, which simplifies to 26 minus 43i once you combine like terms. So number 3, I want to show you the correct method, and then I want to show you the incorrect method, and I want to know why I need to do the correct method. So first off, the correct method. We first need to simplify radical negative 4 and radical negative 9. Put them as their imaginary numbers. So when you multiply radical negative 4 times radical negative 9, that becomes 2i times 3i. 2i times 3i will be 6i squared. Well, remember the I squared is negative 1, so it's 6 times negative 1, which is negative 6. That is our correct answer. Here is the incorrect way of doing this, and I see this a lot. So radical negative 4 times radical negative 9. Oh, they're radicals, so I can just multiply what's inside of the radical, the radicands. So negative 4 times negative 9 is positive 36, which is 6. You can't do that. Look at what it did. It canceled out the negative part. It didn't take an effect that these were actually imaginary numbers, and it just did negative. You just did -4 times -9 to get 36, and it actually didn't take it apart the i's. It just canceled out the i's. But remember, I squared is not 1, it's -1. So that 6 should be negative, and it's not. So you do never want to just multiply the radicands when they're negative. Always simplify them to the imaginary versions, and then once you take out that negative, radical -1, and make it I, then you can multiply the radicands. So when multiplying square roots of negative numbers, why can you not multiply the radicands first? Well, that's because it cancels out the imaginary part of the numbers. Because that would cancel out the imaginary part of the numbers. That's important. See that mistake all the time. And I want to see if you guys can do 4 and 5. 4 is very similar to what we have been doing, so is 5. So just take take 2 to 5 minutes, pause the video, complete 4 and 5, and then play the video when you're done, and we'll go over it. So for number 4, I'm going to first simplify everything I can. That would be 9 plus, take out the I. We have radical 64, which is 8. So it would be 8i. Then 5 minus, take out the I, and you have radical 400, which is 20, minus 20i. Multiply, double distribute. Make sure you multiply 9 by everything on the right and 8i by everything on the right parenthesis. So that would be 45 minus 180i plus 40i minus 160i squared. Combine like terms, 45 minus 140i minus 160 times -1, because that I squared is -1. That would make that 45 minus 140i plus 160, which when you write an a plus bi form, that would be 205 minus 40i. And for 5, make sure you just don't square 1 and square -i. You have to write this out as a product of its factors. And then you would see, oh, I need to multiply, double distribute everything on the left by everything on the right. So 1 times 1 is 1. 1 times -i is -i. -i times 1 plus I squared, -i times -i. Continue to simplify this. You get 1 minus 2i minus 1. And that just simplifies to -2i. That's it for multiplying. Turn the page and we're going to do division. Dividing complex numbers is very similar, as we've been saying this whole time, to dividing radical numbers or radical expressions. So if you look at number 1, just like we can't have an irrational in the denominator, we can't have a imaginary number in the denominator. So we'd multiply the numerator and the denominator by the imaginary part of the denominator, which is I. You could also multiply by 5i. That's just going to lead to, you have to simplify more, like one more step at the end. But I'm going to multiply the top and the bottom by I. So I would get 7i minus 8i squared all over 5i squared. And now let's plug, we know I squared is -1. So 7i minus 8 times -1 all over 5 times -1. Simplify that. That would be, it's plus 8, but I'm going to write it in a plus bi form. So it'll be 8 plus 7i over -5. And remember, we can't have a negative number in the denominator, so I'm going to bring it up to the numerator, change the signs. So that'll be -8 minus 7I over 5. Now, this is key. We got to write in a plus bi form. So I'm going to separate it from its real part and its imaginary part. So negative 8 over 5i, negative 8 over 5, excuse me, minus 7 over 5i. And that is in correct a plus bi form. And that is the correct simplified version of number 1. Number 2, just like we had to multiply the top and bottom of a radical expression by the conjugate of the denominator when the denominator was a binomial, we have to do the same thing when we have a complex number in the denominator. It's a binomial. So remember conjugate, and this is specifically the complex conjugate. The complex conjugate of the number a plus bi is a minus bi. You just change the sign, change the operation from adding to subtraction. Or if it's already subtraction, a minus bi, the conjugate is a plus bi. So very similar to radicals. So we'd multiply the numerator and the denominator by the conjugate of the denominator, which would be 3 plus 2i. And really, think back to it. What's 3 plus 2i divided by 3 plus 2i? Well, it's the same value divided by the same value, so it would just be 1. So we're not actually changing the value of the number. We are just changing how it's written, so we don't have an imaginary number in the denominator. So double distribute the numerator. You get 24 plus 16i plus 3i plus 2i squared. All over, do the same thing in the denominator. 9 plus 6i minus 6i minus 4i squared. Let's simplify that a little bit. We get 24 plus 19i minus 2, because I squared, well, I jumped too far ahead of myself. I squared is negative 1. All over these 6 i's. This is why we do the conjugate. The i's cancel out, and we're left with 9 minus 4 times negative 1. Continue to simplify that. Add like terms in the numerator. Well, that would be 24 plus 2 times negative 1. 2 times negative 1 is negative 2. So 24 minus 2 would be 22 plus 19i all over 9 minus 4. This would be plus 4. Negative 4 times negative 1. So that would be over 13. And just write that in a plus bi form. So we're going to separate the real part. 22 divided by 13 plus 19 divided by 13i. On to number 3. So for number 3, what are we going to want to do first here? I don't see any i's anywhere, but I have negative inside of the square root. So I'm going to want to simplify the square roots first. So the numerator would be 3 minus radical negative I, take the I out, radical negative 9, take the I out, and you have radical 9, which is 3i, so it'll be 3 minus 3i over 4 plus 5i. All right, so we still have an imaginary number in the denominator, so I'm going to multiply the top and the bottom by the conjugate of the denominator, so that'll be 4 minus 5i, 4 minus 5i. And just double distribute, multiply everything in numerator by 4 minus 5i, and same in the denominator, so that would be 12 minus 15i minus 12i plus 15i squared, all over 16 minus 20i plus 20i minus 25i squared. Combine like terms that you can. That would be 12 minus 27i plus 15 times negative 1. And you can write 15 times negative 1 as just negative 15 also. All over 16. Negative 20i and plus 20i cancel out. And negative minus 25 times negative 1, which becomes negative 25 times negative 1, you can just write as plus 25 also. So now I'm going to combine like terms in the numerator. I get 12 minus 15 is negative 3 minus 27i all over 16 plus 25 is 41. So we don't have an a plus bi form. Let's just separate the real. Negative 3 over 41 minus the imaginary, which would be 27 minus 27 over 41i. And that is our answer. So that is operations with complex numbers, the success criteria, and your homework, which is the classwork. That's it.